Hi everyone, we're from Group 21. This video is going to be about latent heat of pure substance. Latent heat can be described as energy absorbed or released by a substance during a change in its physical state that occurs without changing its temperature. Two common forms of latent heat are latent heat of fusion that portrays heat required for an object to go from solid state to the liquid state or vice versa, and the next one, latent heat of vaporization, which can be described as the thermal energy needed for liquid to evaporate to gas, or the amount released when a gas condensed to liquid. Then, we move to the history of the development of latent heat. Joseph Black is a scientist who invented latent heat. He was appointed Regius Professor of Medical Practice at the University of Glasgow in 1757. He deduced in 1761 that applying heat to ice near its melting point causes an increase in the volume of water in the ice-water mixture rather than a rise in temperature. Furthermore, Black discovered that adding heat to boiling water increases the amount of steam produced rather than the temperature of the water-steam combo. Based on his findings, he determined that the applied heat had interacted with the ice particles and boiling water to become latent. The theory of latent heat marks the beginning of thermodynamics. When ice melts, it remains at 0 degrees Celsius and the liquid formed with the latent heat of fusion is also at the same temperature. Next, when the water boils, the temperature remains at 100 degrees Celsius until the last drop evaporates. All of the heat added to the liquid is absorbed as latent heat of vaporization, exiting as vapor molecules. Water has a heat of fusion of roughly 334 joules per gram at 0 degrees Celsius, and for heat of vaporization is approximately 2230 joules per gram at 100 degrees Celsius. This graph shows the relationship between temperature and the internal energy of a substance. The substance is in its solid phase at point A, and heating it raises the temperature to its melting point, but the material remains solid at point B. The energy from the heat source is used to disrupt the bonds that hold the atoms in place when it is heated further. This happens from B to C. All of the solid phase has been changed into liquid phases at point C. As energy is added, it is transferred to the kinetic energy of the particle, which raises the temperature from C to D. Thermal energy overcomes the connections between points D and E, and the particles have enough kinetic energy to escape the liquid. The material is transitioning to a gaseous state. The equation of the latent heat was stated below, which L equal to Q over M. M is the mass of the substance and Q is the amount of energy released or absorbed during the change of phase of substance. For example, given that the latent heat of vaporization of water at 100 degrees Celsius is 2257 joule per gram, estimate the latent heat at 300 degrees Celsius. This diagram shows the MATLAB command for the previous question. Using MATLAB, to find latent heat by substituting the formula with alphabet, we can get the answer for the latent heat of vaporization of water at 300 degrees Celsius. These are the references. Thank you, and have a nice day.